Solid Edge helps designers meet the challenges of form and function in consumer product design by offering unique and powerful tools specific to plastic parts. In a top-down design approach, the trigger switch assembly is subtracted from the supporting ribs, ensuring an exact fit. Here we'll inspect the faces of the part for draft using the Draft Face Analysis tool. We can quickly determine the pull direction and see the colors that indicate drafted and straight faces. This is a quick visual indication we have a moldable part. Another feature that is found in a large majority of plastic parts is known as a web network. These networks of ribs or web features are often used to strengthen plastic parts as well as provide support for internal components. By creating a uniform series of lines in a grid pattern, we can quickly define the center lines for the web network. By building this housing in the context of the internal components, we can ensure everything fits in the design. By physically copying specific geometry from the motor into the housing, we can create a pocket in the web network for the motor to be supported. Another common feature found in many plastic parts is a mounting boss. This feature would take several conventional modeling features and many steps to generate if it were not for the Solid Edge mounting boss command, specifically written to generate this common plastic part design geometry in a single feature. Next, we want to create a pattern of mounting boss features. The exact locations for this pattern of features have been recorded in a spreadsheet of exact X and Y distances from the parent feature. Plastic parts that are made up of two adjoining halves, like this jigsaw housing, often contain interlocking lip and groove features at the parting line. This ensures the alignment of the two halves as well as creates a moisture-resistant seal between them. Here we'll add a lip feature to the inside edge along the top of the housing. Notice that as we simply move our cursor around, we can change the location of the profile and therefore specify creating the lip above the edge. As we pan to the center of the handle area, we'll generate the same dimensional profile, yet by simply adjusting location of the profile into the part, we can quickly generate the complementary groove below the edge. The final plastic part feature we will create is a vent. Many consumer products contain electrical components inside that require airflow to keep them from overheating. This can be a very complex feature that would certainly require many conventional protrusions and cutout features to create without another Solid Edge specific command for generating them. As we return to the top level assembly, we can see how all the internal mechanisms of the jigsaw fit nicely into our ergonomic and functional plastic housing. The internal components are held in place by the internal features of the plastic housing that were created quickly and easily using process-specific features like the web network. As you can clearly see, the plastic part-specific features built into Solid Edge greatly reduce the effort in creating common geometry found throughout plastic part designs. Solid Edge, design better.